On.
All right, folks. So here's what we got going on. I'm just going to give you a little heads up on what the expectations are and how this project is going to work. Sometimes it's a little bit easier to record this kind of stuff than it is to do a whole class because you can kind of watch it at your own pace and kind of have it make sense to you. So experimental design, rate of chemical reactions. This is our Unit 2 practical exam. So instead of a formal exam where you come in and we do some Schoology, multiple choice, stuff like that, you're going to do a lab, you're going to do an experiment, and you're going to do a write-up. And your write-up is going to be what's graded. In addition to all of the information that's given to you in links in the Schoology assignment, this is your main source of instruction. So the first thing you're going to do with this is you're going to pick from experimental question 1, 2, or 3, and that will determine which lab you are going to do from there. So in experimental question 1, we're looking at concentration and how it affects the time of a reaction. You will use a reaction of magnesium and hydrochloric acid. You will change the concentration of the hydrochloric acid by taking the initial substance and diluting it with water. So each time you do a reaction, you'll add a little bit more water to make the concentration lower and see how that affects the time it takes to react. Experimental question number 2. How does the amount of reactants affect the temperature change within a system? So anytime magnesium and hydrochloric acid react, it increases the temperature. We want to look at how changing the amount affects the temperature change. So you would add more magnesium or more hydrochloric acid in order to determine how that affects the temperature change. Is it going to increase the temperature change or decrease it? If you choose to do experimental question number 3, you're looking at how temperature of a solvent affects the dissolving rate of the solute. So you're going to look at how changing the temperature of water can affect how fast you can dissolve salt in that water. No matter which experiment you choose, these are your objectives. Now notice these are group objectives. I am going to allow you to work with one other person should you choose to do so. Now, things that will look the same on your lab report would be possibly a formulated prediction. You may agree with the person you're working with that this is what's going to happen within my experiment. Your design may look pretty much the same in identifying dependent and independent variables, control variables, things of that nature. Your collected data may look the same. Where you start to possibly look a little bit different is in the presentation of your results. Your graphs might look the same. Your data tables might look the same. But then in analyzing them and organizing and then writing your discussion paragraph, that needs to be where your work looks a little bit different than your partner's. So this is not a group situation where you are going to create one document, work on it together, and then submit the same thing. You'll need to have your own document despite the fact that they may end up looking somewhat similar. So formulate a prediction, design an experiment, conduct your experiment, present your results, determine whether or not your results agree, and then go ahead and add that discussion paragraph. So your Google Doc will contain the following. This is outlined in pretty decent detail in the grading rubric, which you can see in the Schoology assignment. And then I've hinted at some important things here. So for example, being very specific in your experimental procedure, kind of like when we did the pancake lab and I made people go back and write in what we're using to measure and things of that nature. You're going to want to make sure that you're identifying the types of instruments and devices that you're using as you go through your experiment, because these are control variables, right? These are things that other people would need to know if they're going to reproduce your results. Discussion paragraph, beginning with a claim, that's huge. Whether or not your results supported your prediction. Make sure anytime you make a claim, you support that with data and evidence. Same thing if you're saying your claim or your prediction was, or if you're saying your prediction was incorrect, supporting that with data as well. Looking at some primary sources of error and how it skewed your data. So not just saying, oh, well, we measured wrong. Oh, really? Okay. Well, how did you measure wrong? Did you measure too much, too little? And if that's the case, how would that have made your data incorrect? How can you account for this error if you were supposed to do this again? So if you were going to do this experiment again, how would you get rid of that source of error? Like I said, the rubric's there. The main thing that you need to do to get started is to pick a question and then start designing your experiment. I want to check procedures prior to you starting. You can start as soon as Monday, assuming that you have a chance to pick a question and start with the procedure. I'll have everything ready to go for us on Monday to be able to do the experiment. So hopefully this is helpful. Let me know.